Bismillahirrahmanirrahim. Assalamu alaikum, dear students. This is our next problem. Problem having been chosen from the book Modern Physics by Paul A. Tipler. As usual, we first come to its statement. Okay. Two spaceships are approaching each other. Two spaceships are approaching each other. Approaching each other may be understood as that they are traveling in opposite direction in such a way that their different distance is becoming smaller and smaller. Okay. Other possibility is that they are traveling in opposite direction such that their difference is increasing, but that is not the case here. Okay, here is the case where their difference is becoming less and less. Okay, two spaceships are approaching each other. Part A: if the speed of each is 0.9 c, where c is speed of light, meaning that relative speed is 9 parts out of 10 of the speed of light, that is to say 90% of the speed of light. Okay, if the speed of each is 0.9 c, speed of light relative to earth, what is the speed of one relative to the other? Part B: if the speed of each relative to earth is 30,000 meter per second, within bracket about 100 times the speed of sound. Okay, 100 times. Okay, it means speed of sound will be 300 meter per second. Okay, because 100 time of 300 is 30,000. Okay, anyhow, this is a separate thing. What is the speed of one relative to the other? Okay, if the speed of each relative to earth is 30,000 meter per second, then what is the speed of one relative to the other? Now we move to solution. Dear students, our solution will be completely based on the basis of this snapshot. Okay, this snapshot has been chosen from some book, but for the time being I do not remember from which book. Definitely it will be a general physics book, because chapter number 39 is always of general physics books nature. Okay, modern physics books have usually chapters in between 12 and 15. Okay, anyhow, now we come to the contents of this snapshot, upon which solution of this problem will be completely based. Okay, the relativistic form of the Lorentz velocity transformation equation is u dash x is equal to ux minus v over 1 minus ux v over c square, where u dash x is the x component of the velocity of an object as measured in the s dash frame, and ux is its component as measured in the s frame. Okay, so we will solve this problem within the ideology, within the philosophy of this snapshot. Okay, u dash x equal to ux minus v over 1 minus ux v over c square. Okay, first we come to part A. Part A: u dash x is equal to ux minus v over 1 minus ux c over c square, equation number 1. Same thing. Okay, no difference. We have reproduced this part. Okay, using, okay, in this equation we will use the following data. Using ux equal to minus 0.9 c, V equal to plus 0.9 C. Okay. Dear students, as I have described, as I have explained that their movement is of such a nature that two spaceships are approaching each other. When approaching each other, it means their velocities are in opposite direction. Okay. So one velocity will be along positive x-axis and other will be along negative x-axis. Okay. That is why we are using here ux equal to minus 0.9 c while v equal to plus 0.9 c in equation number 1. Okay, in this equation, when we will put these two values, then we will get u dash x is equal to minus 0.9 c minus 0.9 c over 1 minus 0.9 c into plus 0.9 c over c square. Yes, students, these two will be added, but their sign will remain negative. Okay, so minus 1.8. okay, that is minus, these two will be added but their sign will remain minus. Okay, one in the denominator, 1 minus into plus, so minus into plus it will remain minus. Okay, so 1 minus 9 into 9 81, and hence it will become 8.1. Okay, in the numerator minus 1.8 c and in the denominator 1 minus 8.1. Okay, this becomes equal to this over 1 plus 8.2, because minus is outside and minus is inside. We know that multiplication of two similar signs always results in positive sign, while multiplication of different signs always result in minus sign or negative sign. Okay, so minus 1.8 c over 1 plus 8.1, this becomes equal to minus 1.8 c over 1 plus 1.81. This alternative becomes equal to 0.9945 c. Okay, it means, dear students, if speed of light is classified into 10,000 parts, if speed of light is classified or distributed in 10,000 parts, then out of those 10,000 parts, 9,945 parts will be equal to this speed. Okay, anyhow, now we move to part B. Using ux equal to minus 30,000 meter per second and v equal to plus 30,000 meter per second. Okay, same pattern as in part A. The only difference is that here not 0.9 c, rather in place of 90% of speed of light, given speed is 30,000 meter per second. Okay, so ux minus and v plus in equation number 1 we get. Okay, same pattern, minus 30,000 meter per second minus 30,000 meter or divided by minus 1 minus 30 into plus 30,000 meter per second. These two will be added but their sign will remain negative. Okay, so minus 60,000 meter per second over 1 minus 30,000 into 30,000, 90, not 90,000, rather it will become so many zeros. Okay, 1 2 3 4, these are 4 zeros, these will become, it will become 8 zeros. Okay, 9 and with 8 0, 1 2 3 4 5 6 7 8. Okay, in the next step, in the denominator we have not changed, however in the numerator we have no change, but in the denominator it has become equal to 1 minus minus 9 with 8 zeros meter square per second square, because meter per second multiplied by meter per second will become meter square per second square divided by. C, we know that value of C is 2.998 into 10 raised to the power 8 meter per second. But we usually take 2.998 as equal to 3. Okay, so C square will be written as 9, because the square of 3 is 9, and similarly square of 10 raised to the power 8 is 10 raised to the power 16. Okay, similarly square of meter per second is meter square per second square. Okay, so here dear students, meter square per second square will be cancelled with meter square per second square. Moreover, these 8 zeros will be subtracted from these 16 zeros. Okay, so 8 zeros will remain in the in this figure. Okay, so in the next step we write it as minus 60,000 meter per second divided by 1 minus 9 will be cancelled with 9. Okay, it will become 1, and because 10 these 8 zeros will be subtracted from these 16 zeros, and hence 10 raised to the power 8 will remain in the denominator. Okay, and it will be written in this form. Okay, because lower part of the denominator is shifted upward, and we can say that here it is 10 raised to the power plus 8. If we shift it to upper side, then it will become minus 10 raised to the power minus 8. Okay, that is why out of these 16, 8 will be cancelled from this, while this 10 raised to the power plus 8 will become 10 raised to the power minus 8 when we shift this above side. Okay, hence in the above step it will become minus 60,000 meter per second divided by 1 plus 10 raised to the power minus 8, because minus into minus will become plus. We know that multiplication of similar signs always results plus sign, while multiplication of different signs always results in minus sign or negative sign. Okay, hence 1 plus 10 raised to the power minus 8. Then we can write 10 raised to the minus 8 as 1 plus 1 over 10 raised to the power 8. Here minus 60,000 meter per second into 10 raised to the power. What we have done? We have taken LCM 10 raised to the power 8, and hence 10 raised to the power 8 plus 1 divided by 10 raised to the power 8. We know that lower part of the denominator is shifted to a numerator. Okay, so this 10 raised to the power 8 is this, and after taking LCM it will become 10 raised to the power 8 plus 1. Okay, dear students, 10 raised to the power 8 is so large quantity that if we add 1 in it, it will not make any difference. Okay, so we replace this factor by simply this factor. Okay, because 10 raised to the power 8 is very large than 1, so we neglect this one and we write it in this form. Okay, next, these 8 zeros will be subtracted from these 12 zeros, and we will get minus 6 into 10 raised to the power 4 meter per second. We can also write it as minus 6.0 or minus 6.00 or minus 6.000 into 10 raised to the power 4 meter per second. And this is the end of our problem. Till next video, Allah Hafiz.